Hello and welcome. In this lesson, we are going to talk about primary trigonometric ratios, and we'll use them to find side lengths and angle measurements. Just to recap what we learned last class, number one, the primary trigonometric ratios are SOH, CAH, and TOA. They're most known as SOHCAHTOA. The meaning of it is that the sine of an angle is represented by the ratio of the side opposite to that angle divided by the hypotenuse. The cosine is adjacent divided by hypotenuse, and tangent equals opposite divided by adjacent. We can use primary trigonometric ratios to find side lengths, but we can also use them to find angle measurements. Remember, though, that primary trig ratios, or SOHCAHTOA, can only be used in special triangles, in only one type of triangle, the right-angled triangles. Now, you can look at it this way. Let's take a look at the formula itself. SOH suggests that we need to find the sine as opposite over hypotenuse. Hypotenuse exists only in right-angled triangles. So if you were given a non-right-angled triangle, we wouldn't even be able to locate the hypotenuse, okay? Because there wouldn't be any. So let's take a look at a couple of examples. So the first example is an example of finding side lengths. We have this right-angled triangle. Usually it's indicated by a little square right at where the angle is. I kind of forgot to write it here. And in this right-angled triangle, which we have named JKL, we know one side is 10 meters, and we know that angle K is 30 degrees. And we want to find out what the length KL equals. Okay, so usually, especially when I write geometry problems, I like to plot all the information on the diagram. So I'm going to write here 30 degrees for the angle K, which is given. Now, once you jot down the information, the next thing that you want to do is label the sides of the triangle by using the terms opposite, hypotenuse, and adjacent. Remember that the angle that we're using in here would be the angle K, which means we need to label the sides in relation to angle K. Remember, hypotenuse is always going to be opposite to angle 90 degrees here. And we don't, that will never change. Now, the other arm, that is the second arm of the angle, remember, from the acute angles, one arm is the hypotenuse, the other arm is going to be one of the sides of the triangle. So this other side that is also the arm of the angle we are referring to is what we call the adjacent. And last but not least, here we have the opposite. We don't have to write the full name of them, right? We usually write H, A, and O. And having everything labeled, now we have to think, what are we trying to find? We need to find KL. So our unknown here would be this side length here. So if we are trying to find this side length, we must think, what side length can we use to find KL? Well, we have to use the side that we're given, which is located opposite to angle 30. So we're going to say, we need to find out the adjacent, and we need to use the opposite for it because that's what we have. So that's all I need to write. And then what I do next is I walk through the formulas and I see where are opposite and adjacent connected to each other, in which formula. Remember, SOHCAHTOA is a conglomeration of 3 different formulas. So I look at SOH, I don't see here connecting O and A. A and H for cosine, that doesn't work either, okay? And I am left in here with TOA, so we're going to say, okay, so that's what I have to use. I have to use the tan ratio. So we'll write that down. So we're going to write that the tan of angle 30, remember that that's the angle we're using, so we have to substitute 30 degrees for the angle equals opposite over adjacent. Now, normally, especially at the beginning when we start learning this, I like to tell my students to write down the formula, but if you want to substitute right away, that should be totally fine as well. The opposite side is 10 meters and the adjacent is unknown, and we can call this by letter x. But one thing that I want to point out, whenever we use a certain variable in the equation, like we use x in here, it is very important for us to indicate it on the diagram so we know what x represents, okay? You could have used also the letter j, lowercase j for this, but I chose letter x, and you can choose, or you have many more options. So the next thing that we want to do is grab a calculator and find out what tan of 30 is. So remember, your calculator must be in degree mode because the angle is given in degrees. So what I'm going to do is I'm going to check with my calculator, and it seems that I have the degree mode in here, so I'm good to go. So to find the ratio of a given angle, we press the ratio itself, and then we press the angle, so we enter the angle, and then equals. So we got the number 0.57735. So if you round this number, it's going to be 0.5774. Normally, I'm sorry, 0.5 774. Normally, when we find the ratios, we like to round them to 4 decimal places. 3 decimal places would be all right too, but it's more accurate to 4 decimal places because a small change in the tan ratio can change the value of the whole thing in here. So that's 10 over x. So what we see in here is an equation. And in this equation, the unknown is x right here. It's in the denominator, and when the unknown is in the denominator, I like to do this. I examine both sides of the equation. I have a number here and a fraction in here. So I make the number in the left a fraction. You can write any number as a fraction, giving it a denominator of 1. The next thing I want to do is use cross multiplication to solve the equation. The reason why I want to use cross multiplication is because, number one, the variable is in the denominator, and I have a single fraction in each side of the equation. So it means that we are allowed to use the cross multiplication here. And that will give 0.5774 times x. So 0.5774x equals 10. Now we need to isolate the variable x. So we need to isolate x from 0.5774. So we'll divide both sides by it. So divide both sides by 0.5774. Okay, 0.5774. And here we go. We got x by itself. And I'm going to go to my calculator again, and I'm going to show you a little trick. So notice that I left in my calculator the answer from the previous calculation, which was the tan of 30. And remember, we're dividing by this number. So instead of typing 10 divided by 0.5774, I will go 10 divided by, instead of typing this number, I am going to write or to type answer. There is a function in every calculator for the answer. In my calculator, I have to press second, and I have to press the negative sign that is to the left of the enter button, and that would automatically enter the number from the previous answer, and that will allow me to find the answer with higher accuracy. And I press enter, and I get 17.3. So we'll say that the value of x is 17.3. And don't forget the unit measurements. We used meters, so 17.3 meters. And that's the answer to the first question. Okay, so remember again, the steps are putting all the numbers on the diagram. Number one, let me write this down. Okay, so numbers on diagram. And these steps are the same for both finding angles or sides. It doesn't really matter. Number 2, label the sides in relation to the given angle. Always referring to the given angle, because that's the angle you're going to use in the formula. Number 3, determine the ratio you need to use, and then solve. All right, so your last step would be solving it. Now, let's move on to the next question. In the next question, again, we have a right angle triangle right here. At Q, we have an 80-degree angle, and we need to find out the sine of the angle P, so that's our unknown. And we also need to find the angle P itself, all right? So let's get started. First, I want to mark all the information given and all the information required. Since I'm asked to find the angle P, so first I'm going to make a note in here, right? So that's my unknown angle. And the next thing that I want to do is take a look at what information I'm given here. So what I'm given here is 2 sides, the side RQ and the side RP. Okay? And then I'm thinking, what's the next step? Refer to this. So all the numbers now are on the diagram. We need to label the sides. Now, in the previous example, we labeled the sides based on the angle given. Guess what? Here, we need to label the sides based on the angle required, because this required angle, when you think about it, has to be in the formula in the formula that we choose to solve for the particular angle. So I'm going to label the sides. Let's not waste more time. So here is the angle, here is the hypotenuse, opposite the angle 90. Here is the adjacent, the other arm of the angle, and here is the opposite, which is across from the angle. The measurements given here are the opposite and the hypotenuse. So again, I'm going to walk through my ratios and I'm going to think, where are opposite and hypotenuse sitting together next to each other? As you see here, opposite and hypotenuse are connected by the sine ratio. So therefore, you're going to write the sine of angle P equals opposite over hypotenuse. I usually like to write OPP for opposite because letter O looks like number 0 sometimes. And then I'm going to write the ratios here. So substitute 8 over 17. So that's it. That's all you have to write. The sine of P is 8 over 17. And that's the exact ratio of it. Okay? So we're going to leave it there. The next question that we need to answer is find the angle P. And that's when things get a bit more interesting. So I'm going to rewrite again what sine of P equaled. And we're going to say that the sine of angle P equals 8 divided by 17. So angle P, or to find angle P when we know the ratios, remember that we need to press that button that has a second function and then sine. So when we do that, then that's what we see on the calculator. And then we have to enter or type in the ratio. So let's see how it works. Your calculator is pretty much the same as my calculator, I'm pretty sure. So remember that when we are trying to find the angle, we need to get inside the ratio, we call it. So we have to press second and sine. Notice how on the screen here we see sine and then an exponent -1. This is not a power, by the way, but it just indicates that it's getting to the inside of the function. So we are trying to extract the angle from the sine ratio. And then we have to divide 8 up by 17 or 7 by 18? 8 by 17, sorry. So 8 by 17. So 8 divided by 17. And then I'm going to close the brackets. So the sine has taken up the ratio and it is going to spill out the angle now. 28.07. So I would give it 28.1, round it to the nearest degree. So angle P is 28.1 degrees. And that would be the answer to this question. Now, say that, for example, you were asked to find the angle R as well. All we have to do, remember, is simply use the sum of the angles in a triangle. And that's how we assure that we have a lot of information in our hand, okay? And here you have some independent practice with finding angles, so feel free to practice some more questions. And that's it for today. I hope this helped. Bye for now.